Today's first talk will be held by Timo Derstappen, and it's all about microservice orchestration. So, have fun.
Do you hear me? Yeah, microphone is working. Fine. So, good morning, everybody. I'm Timo Derstappen. I'm from Cologne, and first of all, the disclaimer: we are building a container infrastructure on top of CoreOS. So, I might be biased towards CoreOS, but I know few things about all the other things you heard about yesterday, so come to me after the talk and talk to me. I think I have an opinion about all of them. Since there were so many vendors yesterday, I decided to not go too much into the higher level, like how to orchestrate services with, for instance, the Mesosphere stack or Kubernetes, or just by doing it with Fleet. I decided to show you a little bit like of the concepts like most of them are using internally. So let's first start with a little story. I just want to make this short and not too boring for you. So you know, there's an outline of every Pixar movie, which is once upon a time, every day, one day, because of that, until finally. And this is all how all the Pixar movies work. And so I made this up for a microservice, for microservices. So once upon a time, there was a small web app. Every day, new features were added, and the users loved it. One day, it became hard to add new features and to maintain it and to scale it. And because of that, popular features were put into separate services with their own databases. Because of that, deployment and server provisioning was automated, and until finally more popular features could be added easily. So this is all about microservices, right? Just a few things to add. This also helps with having small teams. So there are some benefits for the organizational structure with having independent teams, like feature teams where ops and devs and product people sit together, and you can deploy independently. So yeah, at the end you will probably end up with very nice small services that fit very well together. And yeah, it's easy. You can throw away those services because they are so small, and you can just re-implement them if they're not fitting into your actual scale anymore. If you're using some, you know, wrong database, it's not just one database where you put everything inside, and it's hard to switch. You have maybe just one use case and one requirement for a database because of some like write or read patterns, and so you choose a certain database for a service, and the service is small, and if you at one point figure out that this is your bottleneck in your stack, then you can just figure out what kind of database, for instance, would be a better model, what kind of data model would suit you more better. And I guess you will hear about the polyglot persistence after my talk. But the thing is, you can just more easily interchange your services with new services. And as Mitchell said yesterday, there's no period where you have like one consistent or like just one setup, right? So there's always a transient state in your architecture and in your infrastructure, because you cannot design it like from scratch and it just all works. It's just, you know, it works for a certain time, and then something is changing, and you have to cope with that. And for the developer side and the architectural side, the microservices are really beneficial. So that you have the independence to choose whatever tools you like, to throw them away easily, and to not get stuck in a certain, you know, monolithic app or in a certain design failure. So yeah, but those things are not for free. So this is what developers tend to think about microservices, right? So they are like very well organized, designed, and small pieces put together to have like an elastic or maybe like this nanostructure. It becomes very hard, right? So that's what they think about why they want to use microservices to build a resilient architecture, to have scalable distributed software, right? But in reality, it looks like this. It's Death Star's architecture. So the complexity is not gone. It's just moved to the infrastructure. So there's a lot of new complexity because of architectural reasons coming to the infrastructure. So all that automation and provisioning of servers and continuous deployments are between 20 or 30% of your development team is suddenly writing code to create this kind of infrastructures, right? And you're also going to make you also have problems building that. So it's not that you just create that infrastructure in the beginning and it just works. It's also hard to scale that. So, why that moment right now is kind of interesting is that we now have small immutable artifacts. So with the containers, you suddenly have, like, some people said when they heard about the containers, oh no, we're back to having golden images. But it's not true. You have like really small containers that have an interface so that you have a chance to plug them together and create your infrastructure more flexible. But you're still not doing this provisioning at runtime. You create an artifact beforehand. And so you have a clear separation between the build and runtime. So for instance, if you, like, we've automated infrastructure on AWS before, and when you do this with a configuration management that provisions your server at runtime, that means like the autoscaler decides to start another machine, and then you install your configuration management client, and then your recipes or manifest will be executed on the machine, and then you install your packages on the machine, and this takes time, right? So maybe after 10 minutes, your server's ready. But with the containers, you can actually do this in seconds. So that means you can optimize for minimizing the mean time to recovery instead of maximizing mean time to failure. Because failure are going to happen, right? So you want to really have a fast startup time for your services if something is going to fail. And with those concepts you find in CoreOS, you have this immutable infrastructure type of thing also in the operating system underneath itself. And that's kind of interesting because they have that concept where you have like an atomic step from this version to the other version. So there's no transient state within the underlying operating system as well. So all things will be good. But what are we going to use in production? So as I said in the beginning, there are a lot of tools out there, and there's definitely not one size fits all. And I really recommend you, if you're in the process of building such an infrastructure, then have a deep look into all of them. They do common things, but some of them are maybe good for your use case, and some are maybe not. Like some are maybe overkill, or others are maybe just too small and too naive to what you want to build. So there's definitely the need to do evaluation of what kind of orchestration, what kind of network, what kind of storage suits your use case well. And those things are, like most of them are quite young, and they're fast-moving targets. So it's definitely hard at the moment to build such an infrastructure and to actually not choose a technology that might be already deprecated in a couple of months, maybe because somebody decided to either sell his technology to somebody who doesn't care about it anymore, or found out that, for instance, their prototype is not what they originally thought it would be good for. So yes, I really recommend you to have a deep look into what you really need, and what could be, for instance, something you can start with and iterate upon. So let me explain some of the concepts we've been using, and to make especially the life of the developers easier. So with Docker, for instance, you always have the problem that you can link containers on your local machine, and you can use something like Docker Compose to plug together some of the containers, and it's really easy for the developer to do a Docker Compose startup, and then their environment is working. But you cannot do that the same thing in your data center. So there's a concept, and I make an example here called the ambassador pattern. And if you have 3 containers, one is the load balancer, one is the application, and one is the database, then you can have something like etcd underneath, or maybe console, and you can let your database, for instance, write to etcd, like here I am the database. And then you have the application reading from that service registry, where's my database? And then you can have the load balancer that finds the application in the same kind of way. But you can also use something like a sidekick, which is a container that is linked to the database, just a partner container that does that for you. So you can use any kind of database image that doesn't have to know about your service registry. So maybe your service registry in production is different from the service registry on the developer's laptop. Even maybe there is not a service registry on the laptop because the developer is just using Docker links. So and then on the other side, where the application lives, you have an ambassador, which is actually a reverse proxy that is able to look up where the database is in the service registry and is also linked to your application container. And you will get the same environment variables and the same host in the application. Like this is your database. This is your database IP address. This is your database port injected by the ambassador. And so the application thinks the ambassador is my database, talking to the reverse proxy, and the reverse proxy is actually does know where the database is. So this is definitely not useful in all cases, especially not if you have circular dependencies. So if you have a database cluster where all nodes talk to each other, maybe, or need a more flexible solution, it definitely doesn't make sense to let everybody talk through a reverse proxy to each other. But in this kind of like 3-tier application, this makes a lot of sense because you can also move the database to another host, and you don't have to restart the application. It's just the reverse proxy that finds out that the backend is now somewhere else. And you can use a lot of different tools for this reverse proxy. Like if you know I'm talking HTTP to that backend, I can even use varnish and do some caching if I want. So just the varnish talks to the etcd registry and knows where the backends are, but your application just thinks there's one backend I have to talk to. So it's, you know, it's called ambassador pattern, but it's something we already used over years. It's just that it's now with a little bit more dynamic backends. So, and this leads to something I like to call container injection, because it's kind of similar to dependency injection. You have containers that have a single responsibility to actually do something, add some functionality to your actual container payload, something your developers are producing. So in the infrastructure, you have a couple of things that are that you have to do across all the applications, something like monitoring, logging, configuring the network, and stuff like that. So you can do something like this. You can have a container chain, or if you have that in with Rocket or Kubernetes, they call them pods. So these are actually containers that are on one host, and most likely they're somehow bound together. Maybe they're in the same namespace, or maybe they're in the same network namespace. And if you use Fleet, for instance, you can have like co-schedule some containers to the same machine. And so what you can do is you can first have a container that pulls your image or does somehow know how to find where the images are you need. Then you can do configure your storage, like maybe mounting some file system on that machine for that container. Then you can do the network configuration, and most likely this is you will create a network namespace beforehand where you configure your interfaces for that container, and then you will start the container within the same namespace. So there were, like in the beginning of Docker, there were some problems to do that, but I think now you can definitely say, like I started one container and then I start another container that's joining the network namespace of the first container. That's possible, and I think I saw some pull requests that they are working on that you can actually say, okay, this is the network namespace I want to join, because yeah, if you use your own tools or just IP NetNS to create a namespace, you couldn't make Docker work with that. So it will be becoming easier to integrate Docker into such environment. And then you can register your service at the end. And those are just tied together and one single deployable unit for you. So since we're using Fleet, we are doing this with systemd units. And within systemd, you can do this one requires that one and starts after that one. And so you go that direction. So this one requires this one, this one, this one. Like this one is requiring this one is requiring this one, and this one is requiring this one. But you can also do that the other way around. But like this one is requiring this one, but you don't say it should start after, okay? So if you require in that direction and require and after in that direction, the effect is that it starts with this container, then this, then this, then this, then this, and it's up. And if you do stop, it's going the other way. It's like, so you can have a really graceful start and stop of your application. I really like that approach because if you have a system where you just put all your containers on and say, like, start them all, then it's most likely that something will start that requires something and then will throw error messages and up until like the database is online, right? And if you have like run some test environments and you just creating this infrastructure and shutting it down again, like it's really nice to have a clean startup and a clean shutdown, right? So this is something I really like about Fleet. You can use this in Fleet, and you cannot do this in Kubernetes or Marathon. I talked to the Mesos guy yesterday, and he told me that it's actually possible in Aurora, which is something similar, like Marathon, built by Twitter. I stopped when I read that Aurora had 40,000 lines of code or something. So it's like you can read the code of Fleet yourself, and it's just fine. It's a small Go project. So Aurora is definitely another level, right? So another nice thing you can do with this kind of concept is you can have distributed chains. So you can have the database is the upper one. So you do a storage config, network config, database, and then register the service, and then you have the ambassador, which is actually waiting. Because you can do, in systemd, you can do a systemd notify, which actually tells systemd that something is up and running. And the ambassador is the reverse proxy that sits there and watches your service registration up until the database is ready. And when the database is registered, the ambassador actually starts the container and maybe registers for your load balancer. Yes, I already told you that we're using Fleet and systemd for it. Just a few things. You can, of course, use all the systemd features. So there's something like systemd notify, or you can use socket activation. So you will just start those containers when a packet arrives. You can use different types, like the storage config might be a one-shot, so it's not actually a process running all the time. It's just a unit that starts, and after it finished, it continues with the next thing. And so you can do like start and stop in there, but there isn't actually a process running. Yeah, and you can define something like restart on failure in your containers. Like if the developers produce the Docker image that fails because of whatever reason, you don't want to have that chain restarting all the time. And you maybe don't want to let it fail in the beginning when it, or if it just dies, you want to restart, and then you can do restart on failure, and you can define how many times, in what amount of time you want to allow that application to restart. So if it fails just 5 times in a row, you want to say, okay, it's done. It doesn't work. But if it just fails, irregularly, you might want to, start it up. And one thing which makes Docker really hard in that situation, in that use case, is that actually you think the supervision is in systemd because that's your init, and you're actually starting systemd units to start the containers, but it's not. The supervision is in Docker itself because all you do here is using the Docker client to talk to the Docker daemon to start the container. This is somehow not really nice in that setup, and I really would like to have Docker to have a small runtime I can use instead to make it more, make it easier to integrate. Because what's happening here is that systemd, for instance, is using the C groups for units, and you can manage those C groups from within systemd, but Docker is creating the container, and so here the C group tree is broken, and also the process tree is broken. So it's actually hard to find out for systemd what's actually happening here. And all the things you do in the units is actually leveraging the Docker client to tell the daemon to start or stop. And this is not so nice in terms of integration. So if you have a look at Rocket, for instance, it's one of the features of Rocket that makes it like Rocket is not really a competitor to Docker in terms of like what you can do with Docker. So the workflow of how a developer uses Docker on their laptops, you cannot do something like this with Rocket, and it's not intended to be like that. But it's more more suited for production environments where you have orchestration tools and you want to have a nice integration of your container engine into that existing orchestration tools. And I think that's where Rocket shines. Then the problem is, like, I have the same fear, like, do the containers run similar in Rocket that the developers created on their laptop with Docker? I don't know. You can import Docker images with Rocket, and it should work, but it should, right? So we have to look how that will work out, and I still have the hope that the Docker also will provide something that runs daemonless, because that would be really helpful in production. Because the Docker daemon is not something you want to run in production right now, at least right now. So there are some projects that actually do using Docker as an init. So there's Rancher OS, where you have an operating system that uses Docker as an init, which is kind of interesting, but from my perspective and our experience right now, it's really not something I want to have right now, because the Docker daemon is not very good as an init right now. And sometimes you end up in having a Docker daemon that sucks up all your memory, because there are some memory leaks in it, and then you have like just the logs collected in the Docker daemon, and then the Go garbage collector doesn't free the memory, and then you have like 4 gigs of RAM sucked up by the Docker daemon, and this is really not an init process for me. Yeah, these are some problems right now, but I hope they will work on it. Yes, and to show you a little bit how that actually works. This one. Oh, I have to. Yes, this one. Okay. So to make that setup a little bit more interesting, I have that small Linux machine, and I really don't want to run vagrant images on my machine. Like when I work with CoreOS and I have to start up a cluster with 3 virtual machines on that machine here, it's always a pain in the ass. So last year I put together a small wrapper around Systemdnspawn, which is Systemd's container engine, to actually start up containers, 3 Systemdnspawn containers that contain all the tools I need for CoreOS. So yes. Oh yes, I tried before with the dark. I have the light. Is that better? I can make it a little bit bigger. I tried my dark theme, but the dark theme was even worse. Yes? Fine? So where was I? Within the nspawn containers, I have Fleet running, etcd running, of course systemd. I need systemd for Fleet, and I also run Docker. So I have 3 nspawn containers that actually have Docker inside, and then you start containers in those containers. It's just easier for me because I don't have virtual machines that suck up all my memory, and I can show you how that works. So this is just some things. Like I have built something similar, like a Docker file for that nspawn containers, and it fetched a discovery URL from the etcd discovery, and then now the containers are already running. So it's way faster than using Vagrant. And so one thing that also comes with systemd is machine CTL. So you can see those 3 containers running here. And just to give you a little bit information about what I did with networking. So these 3 containers have their own virtual Ethernet interfaces. And so these are pairs, and one is inside of the network namespace and one is outside. And the one outside is bound to a bridge. So the setup is kind of similar to what the default networking setup is in Docker. And I've used systemd networkd for it. So that's kind of nice. Lost my mouse. Okay. So yeah, you can of course see show and spawn. Am I in the way? No, I'm not in the way. So you see that those 3 are bound to the bridge, and then I just briefly show you the network configuration. So with networkd, you have that netdev unit, and this says, okay, this is the name of the bridge, is nspawn 0, and it's a bridge. And then you can do define the network, and you say, okay, this is my address. It's 13.1. I am a DHCP server. I will promote this DNS, and I will add a default route. So when I then start up the containers, within the containers, there's also networkd running, and it's kind of similar inside the container as well. So I have a netdev in there creating an interface that has a network that runs as a DHCP client to that DHCP server. So this was kind of easy to set up with just Linux, systemd, internals. So you can do a lot of things with containers in Linux, in a modern Linux, and like CoreOS is one that is a modern Linux for your data center, and it's kind of interesting. Those features are actually really interesting because the systemd team is watching what's happening out there with containers, and they're implementing their vision of how to run containers on a Linux system, and like it's really interesting to use that with just the things that come with your OS already. So if you don't have a big use case to run a big Mesos cluster, have a look at those things, because it makes it easy to get used to using containers and how to actually have the same things Docker provides just in your bare Linux. So with machine CTL, you can, in the latest version 2.19, I think, you can fetch, you can also fetch images from the Docker Hub, and you can, they use Btrfs underneath to have that fast snapshots, so you can create a container from a Btrfs subvolume. And you can manage those things with machine CTL, and so I don't have the latest version because my demo setup was broken with the latest version, so I went back to 2.18. But you can see, you can do commands here like list, status, then you can log into your containers, you can reboot your containers. It looks similar to what you can do with Docker. So I'm just saying it's kind of interesting, have a look at it, and that's how I created my my local development environment. And oh yeah, one nice thing as well is that you can use your local systemd tools to actually look into the containers. So you can manage the services running in that containers with systemd on the host. Normally, if you think about containers, you have just one process running in a container, and it's just isolation for one single process. But with that, I booted systemd in a container, which is maybe not something you want to do, but you can, and I have a use case for it, because I want to run systemd in a container, and I want to run Fleet in that container. So what you can do is you can actually look inside the container, the Systemdnspawn container, and you can see which services are running inside of the container, and you can do, you can stop them. So I have the Docker service running in there, so you can see the status of the Docker service, and you can also check the journal and see what etcd logged in that container. So it's always the -m for a machine and then the name of the container. So that's the Nspawn setup. So let's move on to this command is just an alias because I'm too lazy to type. So it's I actually call it Flottenkommando. So this is a Fleetctl that tunnels to the first container, the first Nspawn container I created, and so now I can do a list machines and check if all the containers found themselves in etcd, and you can schedule things on those containers with Fleet. So I have them in Fleet. So now you can look list units. There are none, and list unit files. Of course, there are also no. So I have a small setup. So let's go there. So I need some utils, like some tools on all the machines. All right. I will do a watch here, so then you can see this. So this is just installing some things on the core machines that I need for the ambassador and some for the network configuration stuff. So we need some scripts on all the machines. So and they have been installed now. And so what I prepared here is I have two services. Service, this one? Service 1 and service 2. And similar to what I showed you in the slides, so there's one unit that pulls the image. This is the actual container, and this one is registers the container. Then I have a second service with an ambassador that waits for the first service, and in parallel there will be a pull, and then the second service starts. That's all. So, but to get an understanding what's inside those units, I will just go through them a little. So Who of you is using systemd? Oh man. So, who's afraid of systemd? It's fine. Okay. Yeah, I'm using Arch Linux for a while, and when I found out that CoreOS is doing that for my production system, I was actually kind of, that was kind of a selling point for me. The systemd unit is just a declaration of your services you want to run. And what I told you before is that you can use requires and something like after or once, which is a little bit less strict than requires. Because if you do a require and this one fails, then this one will also fail. If you use once, then it waits until utils is started, but it doesn't fail if utils fails. So if you want to deploy a new utils version, you can stop utils and you can install a new version of utils without all the other depending services stopping. This is the difference between once and requires. And so this is a type 1 shot. That means there will actually, this process here will finish, and because I said remain after exit, yes, it will still say, okay, I'm active. I did my job and I stay there active. Yeah, this is an image, like a BusyBox image fetching from my local registry, and here I have some special options that are for Fleet that say, okay, this service 1 conflicts with service 2, so those services are not deployed on the same machine. The next service is the service itself, and so it's what I told you before. You have a start limit interval. So if it fails 5 times in 30 seconds, the systemd will never start this service again on its own. There we just be careful and remove an existing container, because you cannot create 2 containers with the same name, and then it runs this BusyBox. Actually, I'm not running BusyBox. I'm pulling the wrong one. Yesterday I switched to Alpine, which is also a very small container, because the Netcat version I wanted to use was different in the BusyBox. So I'm starting a Netcat server here on port 8080 that pings Google. And the other service, the second one, is connecting to that service on 8080. But I'm linking the ambassador to that service. So it goes through that ambassador, like what I explained before. Yeah, and let's do it. Maybe just do it in a little bit smaller steps, because last time I just did Fleetctl start utils, but that does a couple of things. So what it does, the first thing is it submits the unit files to the cluster. So they won't show up here because they are not loaded onto machines. So list units will not show those units, but you can do a list unit files, and there you can see those services. So they are inactive. You have here a desired state and an actual state. So you can see state transitions in here, and you can see the target, like the machine those units should be deployed on. And with utils, it's a global unit. So the target doesn't, there's no target because it's a global unit. So you can have that X-Fleet options in the systemd unit telling Fleet this is a unit that should run on every machine. So let's load those units. So now, let's go up a little. Those units are loaded onto machines. They're not started yet, they're just loaded. And you can see service 1 is on 4 and service 2 is on 2. Yeah, and then let's just start them. Oh, let me explain before. So again, we will see this one starting first, but also this one starting first, because they're in their chains the first units. But when the ambassador image is fetched, it will stay in starting up until this service is registered. So when this is done, like active running, then you will see that this will continue. So start, it takes a little bit of time. This one is already starting. This one is starting. And this is starting in parallel, yes, because I don't want to waste time to wait for the pull. So this is already, the service is already running, so now it's registering. And start post, running, and then this one should go into running as well. Oh, it failed. Oh man. I did that the whole night. Oh, it's starting again. Yeah, I had some problems with the netcat and netcat through the reverse proxy I was using. Hey, it's running. So let's see. With the Fleetctl, you can also pull the journal from your services, so you don't have to look up where the services are and then connect to the machine. So now, I think there shouldn't be much in the server. Just make it a little bit bigger. So actually, there are a couple of things. This is, Docker telling us that we wanted to remove a container that didn't exist. I just said I did this just for security, that there's no Docker naming conflict. So so this it's failed at one point, yes, and then it started up again, and yeah, there's nothing. But if you because the netcat is not, telling us anything, but it's doing a ping to Google, and we connected to that in the second service, so we should actually see that here. Yes. So it worked. Questions about this? Give me more time and I'll write it down, yes? I mean, this is following the container space since 2 years now, and yeah, it's probably spread around a lot. So you will find about this on several places. Yeah. Yeah. Yeah.
So, in your introduction, you talked about the desktop problem, which we are facing right now. So, I'm not seeing too much how what you showed now, setting up the infrastructure, really helps to solve that problem. Or what are some ways to deal with this dependency nightmare?
So. So the question was how this concept relates to the desktop problem. The thing is, those concepts are not the solution to the desktop problem, but I think that with the immutable infrastructure and containers, you have a clear separation between the actual payload you want to run and the things you want to do for all those services, like metrics, collecting metrics, do your logging stuff, and all those kind of things. And there are nice ways to plug them together, and maybe even use like different things, and but the same kind of images. Like the developers have the same kind of images, and you can release a new version of your logging, and then the developers do not have to care. So I think that's the main point. But with those technologies, you will definitely have problems in that kind of desktop environment right now, because most of them won't scale anyway. So if you take, for instance, Kubernetes, they say with a 1.0, we probably support 100 nodes, which is not much. And you don't know when they announce the 1.0, and I'm not sure about how many nodes they will support right now. So same thing goes for tools like Fleet or etcd. So there are a couple of things we figured out that, yeah, of course they are not like advertised on their websites, right? So just as a recommendation, if you use etcd, I highly recommend you do polling instead of watching right now, because they have a small buffer, and if you do consistent watches on the leader, if you do consistent watches, they will go to the leader, and if there are a lot of writes coming in, the buffer is too small, and you will actually not, you will miss some of the changes. And actually, from a consistent key value store, you expect to get all the information, right? So this will definitely hurt you. So use polling instead of watching, or at least do not use too many watches, or do not write. And same goes for Fleet. So Fleet is really not optimized at the moment, and it's doing kind of wasting a lot of CPU. If you add machines, so you have an agent running on each of the machines, and it's looping through all the units in etcd every 5 seconds, and because of bad implementations, they are doing this twice in every loop, parsing all the JSON of the etcd structures, and these are not things that are hard to fix, and we are currently fixing a couple of those, because in our infrastructure at 1,500 containers, there was just no way to go further, because the system started to implode, and yeah, and I want to have a couple of zeros behind that 1,500 containers. So, yeah. Yes. And I feel the pain. Yes. I think for us it will be, we're going to move our own containers those in that chain that we are providing, and also all our services into Rocket. I think the latest releases of Rocket are now supporting the things we need. And a couple of things with volumes, and but it looks really nice, and it better suits us. So we will definitely put our own stuff into Rocket first, and then we will have a look if it's really a problem in terms of dev prod parity, if we run containers from developers in Rocket instead of Docker. So we have to, see if that works out or not.
Do we have any further questions?
How do you deal with data systems? Do you have data for your
We're currently building a bare metal setup, so the storage will be more interesting there, because we, in the first place, we developed the whole stack on AWS, and we just used EBS volumes, which were mounted, like attached to the host, mounted, and then bind mounted to the container. That kind of worked, but it's not really nice. So there's a reason why Amazon announced their EFS, I think it's called, the NFS thing for the cloud. Yeah, we are looking into a solution right now coming from Berlin here. It's a proprietary file system called Quobyte, but it looks really promising and interesting. And we're probably not using Ceph something. And we're not using, expensive hardware, and we're not buying something from a hardware vendor.
Okay. Thank you very much, Timo.
Thank you.